Hey everybody, this is a video for my intro calc students, and this is actually, we'll just call this 3 more examples from 1.4. Decided to spend an extra day on 1.4, getting lots of questions through EDSB of people who are feeling a little stuck. So I thought I'd go over 3 examples, but I want you to kind of try them first. If you've been keeping up with the assignment, keeping up with the homework, you should have at least an idea how to get going on these. So let's start with this one. Copy this one out. We'll do this one using both Formula 1 and Formula 2. It says find the equation of the line tangent to the curve y equals the square root of x plus 2 when x equals 2. So if you know how to get this started, then please do pause the video and try it for Formula 1 and Formula 2. And I'll be with you in just a moment. All right, did you give it a try? So Formula 1 is you find slope when you find the limit as x approaches a of f of x minus f of a all over x minus a. Okay, in this case, why don't we just find f of a? F of a would be, well, x is 2, so that's a. And if I put a in for x here, f of a is just going to be, well, it's also going to be 2. So actually the point here that we're finding the slope at is the point 2, 2. So again, this is a, and this is f of a. So in the formula here, it's going to be the limit as x approaches 2 for f of x, which is the square root of x plus 2, minus f of a, which is 2, all over x minus 2. And right here is where you should recognize that you're going to have to do some algebra. Because if we just plug 2 in for the denominator, we're of course going to get a denominator of division by 0, and you can't do that. So that's going to need some algebra work. So what we're going to do is, I think, do the conjugate. So I'm going to times the top and bottom here by the conjugate, which is x plus 2 and a square root plus 2. And whatever you times the top by, you have to times the bottom by the same thing. Think of this as a 1. So if I times this thing here by a 1, I don't change its value any. So the numerator is going to be, FOIL that out, first times first, which is x plus 2. And then, of course, outside times outside and inside times inside end up canceling. That's why you do a conjugate in the first place. Minus a 4, because that's last times last. And the denominator I'll leave kind of in this factored form. You'll see why in a minute. And there you have it. So from there, that's going to equal the limit as x approaches 2 of x minus 2 all over x minus 2 times the square root of x plus 2 plus 2. Those cancel, and I get the limit as x approaches 2 of 1 over the square root of x plus 2 plus 2. And I no longer have, oh, sorry, I'm off the screen. I no longer have the issue with the denominator that I had when I had the factor x minus 2, which would be a factor of 0. This won't be 0, so I'll actually plug in my limit. So that's 1 over the square root of 2 plus 2, which is, of course, 1 over the square root of 4, which is 2 plus 2. So the answer is 1/4. Okay, so there it is using Formula 2. Let me sharpen my pencil a little bit here. Or sorry, that was Formula 1. Now I want to do Formula 2, so let's go back to the start here. Formula 2 is when you find the slope using the property that it's the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, so in this case, that's going to be the limit as h approaches 0 of, well, a is of course 2, so this is f of 2 plus h, here I'll write it out, 2 plus h minus f of 2 all over h, which is the limit as h approaches 0. Okay, so f of 2 plus h means I have to plug 2 plus h into this x. So that's the square root of 2 plus h plus the 2 that's already in there, minus, and I already know what f of 2 is. F of 2 is just 2 all over h. So the goal here is to make this h go away, and once again I'm going to have to use a conjugate property, because this is going to be the square root of 2 plus 2 is 4. So I'm going to, at this point, multiply by the conjugate of that radical, which is h plus 4 plus 2. And that's going to yield the limit as h approaches 0 of first times first, which is h plus 4, and last times last, which is minus 4, and that works out really nice, as you can see. I'm just going to leave the bottom in this, again, factored form. And notice that those two terms cancel one another, which is very nice, because that allows me to have a factor of h on top and a factor of h on the bottom, plus all this nonsense here. So the h's cancel, and I am left with the limit as h approaches 0 of 1 over the square root of h plus 4 plus 2, and once again 0 doesn't make this denominator 0, so I can just plug it in. So that's 1 over the square root of 0 plus 4 plus 2, which is again 1 over 2 plus 2, which is 1/4. So we got the same answer in both cases, which is good because both things are the same thing. And I wasn't quite done there, though. I was supposed to find the equation of the tangent line. So remember that I can use this formula, y minus y1 equals m times x minus x1. And for y1, I'll just remember the point that this slope happened at was the point 2, 2. So that's going to be y minus 2 equals 1/4 times x minus 2. And if the question just said find the equation and it didn't say how it wanted the equation, I'm done there. But a lot of the questions have been saying standard form, and I think that's kind of the go-to for your textbook, is to change these to standard form. So to change this to standard form, I would first of all multiply everything by 4, because that'll eliminate this fraction, and I don't have a fraction to deal with. And then I'd move everything to the side where x stays positive. So x minus 4y, and then I'd add 8, so that'd be plus 6 equals 0. So there's the equation. And just to show you how this looks, I wanted to kind of show this on Edsby. So let's see, let's go to, or Edsby, sorry, I meant Desmos. Sorry, I was just updating Edsby, so I was thinking of Edsby. So yeah, so in Desmos, here's the original function, right? And I want the slope at this point. So now here's the equation I got, and you can check your answers to see if they're reasonable by just checking by running this equation through and asking, does it look like a tangent line? And yeah, it clearly does look like a tangent line. It only touches at this one point. So it looks like we've done the first one right. All right, so that's the one we're going to call example 1. Example 2 is going to be this guy here. So take a second and copy that one out. Find the equation of the tangent to the curve f of x equals 1 over x plus 2 when x is negative 1. This time I think we're going to focus on formula 2. I don't want to spend an hour on this video. And what I've noticed looking at some of your homework is that on questions where they give you a choice, it doesn't say which formula to use, you guys all kind of tend to gravitate towards formula 1. But formula 2 is in some ways a little more important for what's going to come in the next couple of chapters. So I think I'm going to stress formula 2 for this example and the next one. So pause the video here and try to use formula 2 to see if you can find the slope. All right, how did that go? All right, so let's see. I am going to start by, well, first let's write out formula 2. M is the limit as h approaches 0 of f of a plus h minus f of a all over h. And, okay, f of a, so a is negative 1. So a f of a would be negative 1, comma, and let's run negative 1 through this formula. Negative 1 plus 2 is 1, so 1 over 1. So there we go. F of a is 1. So let's plug things into the formula now. So f of a plus h is really f of negative 1 plus h, which I'm just going to write as h minus 1, minus f of a, which is 1, all over h. Okay, let's put this into the formula now. So that's the limit as h approaches 0 of f of h minus 1. So the original function is this. I have to replace its x with h minus 1. So it's going to be 1 over h minus 1 plus 2, all minus 1 over h. This is the part that some of you are really struggling with. This here, this is saying take the function and put h minus 1 in where its variable is. Everything else about the function has to stay the same. This 1, this 2, they're right there. All I've replaced is x was replaced with h minus 1. And of course this minus 1 is still f of a's minus 1. So that's equal to the limit as h approaches 0 of, let's see, minus 1 plus 2 is 1 over h plus 1. Now, I'm going to have to combine these two things, so why don't I just do that right now? Let's change 1 into a better version of 1 with this common denominator. So I'm going to change that to h plus 1 over h plus 1. And there we have it. Now I have a common denominator, so I can just combine those. So it's the limit as h approaches 0 of 1 minus h minus 1. Get it? I have to subtract both of those things, so that's why this 1 became a negative. It's really the minus of this positive 1. All over h plus 1, because that's the common denominator, so I just combine the numerator. All over h. Now this is nice. 1 minus 1 is gone, so I have the limit as h approaches 0 of negative h over h plus 1. And instead of dividing by h, why don't I times by h's reciprocal, because that's what you do when you're dividing fractions. The h's now cancel. That's nice. So I get, here I'll just move sideways, the limit as h approaches 0 of negative 1 over h plus 1. And since I can now plug in my h, my 0, because it won't make the denominator 0, so that's going to equal negative 1 over 0 plus 1, which is negative 1. So that's the slope. I'm supposed to find the equation. Remember that the point that we had was, this was at the point negative 1, 1. So let's use our equation again. That would be y minus 1, that's this one right here, equals my slope, which was negative 1, times x, and it's minus negative 1, so I'll just call that x plus 1. And once again, I think I'll use Desmos to see if I've got the right answer. So remember, my original function was this guy here, 1 over x plus 2, which is one of those functions where the two arms go off to infinity, but it's been shifted 2 units to the left from where it usually sits on the y-axis. And this time, just to show you that you can do this, instead of actually figuring out what f of negative 1 is, you know, you can let Desmos do that for you. Put the point down and go, and look at that. It'll even tell you, look, there it is. F of negative 1 is 1. You could save yourself some calculating time. And you can even use that same logic in the point slope formula. That's y minus y1, which is f of negative 1, equals the slope times x plus 1. So that's the same equation we had a second ago. And as you can see, yep, that definitely makes for a tangent line. It's only touching it right there. Okay, one more example, and this one's going to be a little different. This one's a little strange compared to the other ones. So check this one out. Create an equation for the slope of, that says of, the tangent to the curve f of x equals square root of 2 plus 1 at a point where x equals a. Aha! We're not actually giving you a number here, so we're going to end up with a formula that has a in it. So feel free to give it a try. Pause the video and try it. I'll have a sip of my drink. All right, how did that go? Did you give it a shot? Did you come up with a formula? Let's see. Once again, I'm going to use formula 2. So here's what it looks like. It's going to be m is the limit as h approaches 0 of f of a plus h minus f of a all over h. Now, what do I know? Well, let's see. A is, of course, in this case, actually a. It's not going to be replaced by a number. So I'm going to have literally a plus h plugged in to this formula here. And of course, f of a will just be 2a plus 1. So that's going to be the limit as h approaches 0 of, so replace in the function the x with a plus h. So that's the square root of 2 times a plus h plus 1 minus, now replace in the function the x with a, 2a plus 1 all over h. Now, that looks kind of nasty, but we can simplify it a bit. Let me move over so I can do more than one on a line here. So that's going to be the square root of 2a plus 2h plus 1. There we go, expanding that bracket, minus the square root of 2a plus 1 all over h. Once again, I don't really have any way I can approach this other than to try the conjugate pair. So I'm going to multiply this by 2a plus 2h plus 1 plus square root of 2a plus 1 all over h. That's a 2. Sorry, my writing's getting a little sloppy here. There we go. Okay, so conjugates means that when you multiply it out, you'll get a difference of squares, which means you'll have no center term, no middle term. So it's just first times first, which is 2a plus 2h plus 1 minus last times last. Now I'm going to put last times last in a bracket to remember that I'm minusing all of it. It's so easy to lose track of a negative when you're doing these. All over h. And look at how nice that's going to turn out. That is going to turn out to be 2a minus 2a, so the a's are gone, and 1 minus 1, so those are gone. So I'm getting the limit as h approaches 0 of 2h. Oh, wait a minute, sorry. Well, hang on. What did I do that for? Hang on. Sorry. You're probably wondering what the heck I'm thinking. I have to times top and bottom by the same thing, or else I've violated all kinds of algebra rules here. There we go. So top and bottom have to be the same, because again, you can't change what this expression is, and right now I've just times it by a great big number 1, because it's the same thing divided by itself. But that's going to mean that this bottom is now kind of complicated. It is 2a plus 2h plus 1 plus square root of 2a plus 1. And there we go. Okay, that's the end of a bracket. Make that a little prettier. There we go. Now we're good. So the numerator ends up again being 2a cancels, the 1's cancel. I am left with 2h over h times this monster thing. 2a plus 2h plus 1 plus square root of 2a plus 1. And as ugly as this thing on the bottom looks, it has something going for it. When I plug 0 in, I don't get a 0 once those h's cancel. So I am looking at, and I think I'll just go right to my limit here, 2 over the square root of 2a plus 2 times 0, right, because h is being replaced by 0, plus 1, plus the square root of 2a plus 1. And even that simplifies a bit, since this just goes away. You're actually going to get 2 over the square root of 2a plus 1 plus the square root of 2a plus 1. And I can just combine those into 2 times the square root of 2a plus 1. The 2's cancel, and there is my nice simplified answer for a slope. So if you give me an a value, plug that number into there, and that'll be the slope at that point a. And we can show that once again with Desmos. So with Desmos, first of all, go back to the original equation, which was the square root of 2x plus 1. And let's see, Desmos. Okay, so there we go. There's the original equation, square root of 2x plus 1. I had to call it g of x because I already have f of x on this. And then I put a point a, g of a, which could be any point. Notice it's not defined. And as soon as you do that, as soon as you bring in a new variable, it asks you if you want to make it a slider. And I said, yes, please. Let that be a point I can slide around. Notice if I slide too far, I disappear because this function doesn't start until you get to the negative 1/2 point, right? Negative 1/2 would be the starting of this function, right? Negative, there it is, negative 1/2, and then it slides that way. I could get you to, you could label that point if you want, and it'll even tell you what it is as you move along, which is very nice. And now this looks like a hot mess, I'm sure, but really it's just the point slope formula. It's y minus y1, there's y1, equals, there's that slope expression that I just got, so slope times x minus x1, which there's x1. So once I turn that on, this should be a tangent line. And it is. And this is cool. I can slide the tangent line around and find whatever you like. Cool, huh? So there's 3 more examples. Hopefully that helps with some of the tougher questions in 1.4. And I'll post a 1.5 video as soon as I finish making it. Thanks for watching.